Okay, so sorry for not making this last night. It's Saturday morning. Let's get this done. So simplify the expressions. Uh-oh. I gotta write this. Okay, here we go. So you want to put the like terms together, and I highly suggest you know, do this. So let's the m's come together, case, and the case, and then we have a constant here at the end. And make sure you put the sign preceding it that comes before it together. So the 14m minus 8m, and then, ooh, that says minus 7k. Please tell me that's not a minus 7k, is it? Oh, it's plus 7k. Okay, so plus 7k minus k, and then I think that's a plus 15 at the end. So I can combine these two, 14m and minus 8m. I can subtract these two because they're the same variables, the same exponents. So 14 minus 8 is just 6, and I'll put an n. 7k minus k, remember there's a 1 over here, 7k, so 7 minus 1 is 6, so plus 6k. And the plus 15 at the end. So my final answer is this. For this one, I can't combine anything yet until I get rid of these parentheses. So I'm going to do distributive property first. So 6m4, I'm going to just copy these. 12m minus 2m4. And I'm going to take care of the distributive property. So it's going to be plus 15m. And 3 times 6 plus 18. Now that once I do the distributive property, the parentheses are eliminated. I can combine like terms, and I take this guy out and this guy. They're going to be next to each other. And then the plus 12m was a plus 15m. And I'm going to leave the last one alone because just one constant. So 6m4 minus 2m to the fourth power plus 12m plus 15m plus 18. All my like terms are next to each other. M4s I can subtract because they're the same kind, same variable, the same exponent, so that's just 4. 6 minus 2 is 4. M4. This is an addition, 12m plus 15m, so I get plus 27m. Finally, plus 18 at the end. Right? So now it says evaluate the expression or use order of operations. So let's take care of the parentheses first. I can do 9 squared, so that's not going to hurt anything, right? It's not effect. So 81 minus, and inside the parentheses, I'll sort of do it slowly. 24. I'm going to change that divided by 2 to the third. 2 to the third is 2 times 2 times 2, which is 8, minus 2, and then plus 16. So now that everything is just a number, there are no exponents, I can do more things. So 81 stays as it is, minus, inside the parentheses, 24 divided by 8 is 3, and 3 minus 2 is 1. So I get a 1 over here, and then plus 16. So now I have simply 81, and I'll write it a little better. 81 minus 1 plus 16. 81 minus 1 is 80, and then plus 16 is 96. Please follow order of operations. So here, in this line over here, don't do 1 plus 16. It's when it comes to a choice between subtraction or addition, it's from left to right. Okay, so 81 minus 1 should have been first. Here, so again, let's take care of the, so 4 to the third power, let's take care of the exponents. Okay, so basically I want to change everything that's an exponent to just a standard form to a number. So 4 to the third is 4 times 4 times 4, which is 64. So I'll rewrite that, plus 16 times 3, put a dot there, minus 12, and everything, once I finish once I finish adding or multiplying inside the parentheses, I'm going to raise that to the fourth power, and then minus 250, which hopefully will work. So I get 64, and again, I'll keep the parentheses, plus 16 times 3, which is 48, minus 12, all that raised to the fourth power, minus 250. So now let's do this, 64 plus 48, and I'll do this on the side here. 64 plus 48 is 12, goes 1, 112. And then I'm going to subtract minus 12, and that's going to just give me 100. So this is going to be 100 to the fourth power minus 250. 100 to the fourth power, it's going to be 100 times 100 times 100 times 100, right? So 100 times 100 times 100, and that's not the right way to write it, but that's what we're doing, right? So we're going to multiply 100 times itself 4 times, so it's going to be 1, 2, 3, 4, 5, 6, 7, 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8, minus 250. So I'm going to get this. So it's 100 million minus 250. So that's going to be 999, 999, 750. Okay. Translate to an algebraic expression. So I think one of the easiest way of doing this is just literally translate them as they are and then make any changes after. So I'll show you what that means. So let's do this one by one. 3 means 3. More than means plus. Quotient. Quotient is implying division. So I'm going to put a fraction sign because that's what I'd like you to use for division. And quotient of a number that I don't know, so we're going to represent that as n and 2. So this is going to be equal to 3 plus 4n. Next one, 7 means 7, right? Less than is a subtraction, but be careful because less than is a turnaround word, so we're going to have to switch places. So the 7 is going to go to the end, and whatever is here is going to go to the front. So let's take care of translating first. So 7 is 7, less than is 10, 3 times. Multiplies 3 times the difference of a number and 4. So difference means subtraction of a number and 5. But I shouldn't write it this way because I'm multiplying the 3 times whatever I get from my subtraction. So that has to come as a parenthesis. So 3 times the difference of a number 5 it's this. Because if you leave it as this, it says 3 times a number and then subtract it by 5, which is not what I want. I want to subtract these two first and then multiply by 3. Now, don't forget that this less than means I'm going to have to switch places, right? So 3 parentheses n minus 5 will come to the front and the minus 7 will go to the back. So I got to switch places between this term and this term. Okay. Next one, 4 is 4 times the sum of a number and 6. So I got to multiply 4 times whatever I add. I got to add these two first and then multiply by 4, and then therefore I have to protect that addition with a parentheses. I make sure I put it in parentheses because I got to add this and then multiply by 4. Okay, so it's 4 times n plus 6 divided by 5. So divided, and then I'm going to use my fraction symbol, divided by 5. So that's what it looks like. Okay, but if you did write it the other way, plus 6 divided by 5, that would have been just fine too. But this and this are exactly the same. Again, last one, 10 is 10. Subtracted from, careful. It's also a turnaround word, so I'm going to switch to 10. And we're going to go 5 times. We're going to multiply 5 times what? The difference of a number 2. So again, this has to be protected by parentheses, a number and 2, because that subtraction has to occur first and then multiply by 5, okay? So that's what that line says. And now I got to switch around. So 5 is going first, and minus 2, minus 10. So this is my final answer, okay? Okay, so let me just move things around. Actually, what I should have done is make this smaller, sorry. So that's the moon. So now we go a squared, b squared, c squared. That's not that difficult. Let's replace the variables with the given values. So we have 3 squared, right, because a is 3, times b squared, which is 2 to the second power, times c squared, which is 6 to the second power. So we got 3 to the second power times 2 to the second power times 6. Don't multiply anything yet. Just make sure you get rid of the exponents. So 3 squared is 9, 2 squared is 4, and 6 squared is 36. So 9 times 4 is 36, and 36 times 36, I have no idea. And we'll do this. 36 go 18, 21, 18, 9, 10. It's going to be 1,296. That's my final answer. Again, I will replace my variables first. B is 2 to the second power. Make sure you put this little dot there because otherwise it becomes 32. Minus a squared, a is 3 to the second power. And again, don't do anything yet until you get rid of the exponents. So this will be 3 times 2 to the second power, which is 4. 3 to the second power is 9. Now I can do my operations. 3 times 4 is 12, minus 9. That's going to give me 3. Oops. For this one, B, so let's translate. So B, what is B? B is 2, so it's going to be 2, and A is 3, so let's put it over here to the 4th power. And 2 to the 2/3, the 4th power is 2/3 times 2/3 times 2/3 times 2/3. So when you're multiplying fractions, numerators with numerators, denominators with denominators, so it's 2 times 2 times 2 times 2, which is 4, 8, 16. 3 times 3 is 9, times 3 is 27, times 3 is 81. Final answer, 16 over 81. 5 times C, which is 6, times A, which is 3 to the 3rd power, minus 2 times B, which is 2 to the 2nd power. Okay, so before I do anything, let's get rid of these. 3 to the 3rd is 927. 2 times and 2 to the 2nd power is 4. Now I can multiply. 5 times 6 is 30 times 27. 27 times 30. 0, 21 goes 2, 810. 2 times 4 is 8. And that's going to give me 802. Okay, so you're given a rectangle. I'm asking for the perimeter, so I'm giving you a rectangle. So it's always nice if you can draw it. And I'm asking you to tell me what the length is here. How can we describe the length given our situation here? So the length, this is the width, right? And the length is what? The length is 5, because 5 more, right? 5 more, which is addition, 2 times the width. That's what my length is. So the length here is 5 more than 2 times the width, which means this. So let's say, for example, that I gave you a rectangle and I told you that the width here is 2. So for you to find the width, and I asked you what is the value of the width, well, you would use this expression, 5 plus 2w, and you would find, so if the width is 2, you would substitute here and you get 5 plus 2w, which is 2, and 5 plus 2 times 2 is 4, the width would be 9, right? So it's telling you that the length is twice the width plus 5. So it's twice the width, 4 plus 5, that gives you 9. Now the length here is 7 times, okay, so here again, so the length is 7, less that means subtraction, and 3 times the width. Okay, so we have a rectangle here, and the length is 7 minus 3 times the width. So if I told you that a rectangle is here, and that the width of this rectangle was 1, how much would this length be? Well, you would put this one over here, right? So it'd be 7 minus 3 times 1. 7 minus 3 times 1 is 3. So the length would be 4. All right, so I'm describing the length in terms of the width. Distributive property, by now you should, again, this should not be a problem to you. 4 times 5k is 20k. 4 times m is just 4m. So that's the new expression. So this expression and this expression are equivalent. Okay, so this one would be 7 times 3 is 21a. 7 times 5 is 35c. So that's a plus, sorry. Minus 7 times w is 7w. So that would be my expression after applying the distributive property. So remember, you're taking this 7 and multiplying by every term inside. Hang on a second. Determine the property used. Okay, seriously. It shouldn't be that difficult. And let's go. So 5 plus 7 is 7 plus 5. This is the community property of addition, right? That says if we switch the order of our numbers here, it doesn't change the sum. Community property of addition. I'm not going to write up addition. Here we got k plus w plus k plus m, and here we have w plus k plus m. So you know that it's the same three values being added, but in here we added w plus k first, whereas on the right side I am adding k plus m. So this is the associative property, which says that the order in which you group numbers to add will not change the answer. So associative. So make sure spelling will count. And let me just write it better. So this is the associative. Over here is 12 times 8 times 7, and here's 12 times. So this is the associative property of addition. Associative property of addition. Actually, let me take that out. Of property of addition. This is the associative property of multiplication, right? Because I'm multiplying 12 and 8 first here, and 8 and 7 on the other side. So again, the order in which you multiply these three numbers, it does not affect the product. And 9 times 7, sometimes, wow, this is the community property. Sometimes I wonder what I'm thinking when I give you these problems. Community property of multiplication. Multiplication. Okay? Sorry, I'll write it out. Multiplication. Okay? Write an expression and then evaluate the expression. Okay, so we've done this in class. So here's an airplane has 5 gallons of gas. It's already in the tank. It's being filled at a rate of 20 gallons per minute. How much gas will it have after 8 minutes? So there's two things you need to do here. First is the expression. So I know that the airplane has 5 gas, right? No matter what, it already has started with 5 gallons. Not too much. It has 5 gallons of gas plus, and then to that 5 gallons, I'm going to add 20 gallons every minute. So times m. So that's my expression. Now the question is, how much gas will it have after 8 minutes? Well, I'm going to use the expression to calculate that. So there is 5 gallons already in the tank, plus I'm going to take the 20 gallons and multiply by 8 because it's 8 minutes. So 20 gallons per minute. So in 8 minutes, how many will it have? So 5, it's already in there. 20 gallons per 8 minutes. That gives us 160. So after 8 minutes, it's going to have 165. So all this is necessary. Sam has typed 240 words. So far, she types a rate of 50 words per minute. How many words will she have written after 35 minutes? Well, she's writing some type of essay, I guess. So far, she's written this much. So this is what she has. Plus, every minute, she types 50 words. So it's going to be 50 times the number of minutes. And that's my expression. So if she continues typing for 35 minutes, so 240 she already has. Let's figure out how much she has after 35 minutes. So it's 50 words per minute, so times 35. So let's multiply that. 35 times 50. So 250 she already had, plus she typed for an extra 35 minutes. That gave her 1,750 words. So the total would be whatever she just typed plus whatever she had. So plus 240. It's going to give us 1,990 words after 35 minutes, okay, because it includes what she typed in 35 minutes plus what she already had in the beginning. Now these are formulas, and remember what formulas are. We can use formulas if we can use formulas for to calculate certain things because the relationship is always the same. So this is a distance. To find the distance that you travel, you can just multiply the speed of what you're traveling at times the time. So distance equals r times t. Let's substitute. So I'm wanting to find the distance, so that stays. The speed which you travel was 75. The time, in this case, the time is in hours. So the time was 9 hours. So if you drove at a speed of 75 miles per hour for 9 hours, how far would you be? Well, 9 times 5 is 45, plus 4, 67, 675 miles, which is pretty good distance. Temperature. So this is a formula for you to change from Fahrenheit to Celsius. Okay, so C equals 5/9, and if the temperature in Fahrenheit outside was 95, which is a pretty hot day, right? Minus 32. Let's see what that would be in this in Celsius. So 5/9. Let's find out what's in the parentheses first. 95 minus 32. 3. 9 times 3 is 63. So my temperature in Celsius will be 5 nines times 63. So I'll do that. 5 nines times 63. You can put the 63 over 1. 5 times 63 is, let's see, 15 goes 1, 315 over 9, because 9 times 1 is 9, and we can divide that, right? So 9 goes into 3 times, so it's 9 goes into be 35 degrees Celsius, I believe. So 315 divided by 9 is 327, 4, 5, yeah, 35 degrees Celsius. So if anybody tells you, ask you what 95 degrees in Fahrenheit is, that its equivalent temperature in Celsius would be 35 degrees Celsius. Okay. So another way you could have done this is when you multiply 5/9 times 63, you could have simplified before you multiplied. So let me put the 63 over 1. So I can simplify 9 and 63. 9 divided by 9 is 1. 63 divided by 9 is 7. And 5 times 7 is 35. So that's another quick way of multiplying. Simplifying before you multiply instead of doing all that. Okay. Use property. So again, you did that exercise on Friday, and I'm just asking you to justify your steps here. So it's let me write properties over here. Properties, TIES. Okay. Not YS. So properties. So the first property I'm going to use is the distributive property, and that's going to allow me to get rid of the parentheses. 5 times 9 is 45m. 5 plus 6 is 30. Plus 12 plus 15m. Remember that the 5 is not multiplying these two guys. It's only multiplying everybody who's in the parentheses. So that tells me, so I just created an expression that's equivalent to this one. So that's one expression I just created. Okay, these and this are equivalent, except they're just written differently. What can I use now? I can use community property, and I can move things around, right? The community property, so I'm going to write 45m, and I'm going to bring this 15m guy here next to it. So 15m, and then plus 60 plus 12. The associated property, okay, I can group these two, right, to add. So I'm going to get 45 and 15 is 16m. So actually, I should have done that. I should have done like this, because that's how we did it in class. So 45m plus 15, I'm going to group these two, add these two, plus, and I'm going to take 60 plus 12, and then step 4, simplify. So I'm going to get 16m plus, and 60 plus 12, 72. So this is my second expression. I have 1 and 2. So if I give you this original one, you can say that you created this expression using distributive property, and you created this expression after you combine all the like terms. So you have 16m plus 12. So all these three, this one, and this one, are equivalent, except they're written differently. Same thing on the other one, properties. And distributive properties first. right? Because there's a parenthesis there. Get rid of that. So that's 36W plus 15 plus K plus 12. Let's combine that, not combine, let's put the commutative property, U. And so I'm going to get 36W, oops, plus K, I'll move that there, and then I'll move the 15, the constant 15 and the constant 12 next to each other. And in this case, I'm just going to go straight to simplifying that, right? This associative property. Simplify because I only have these two that are alike, right? These are alike, so 15 plus 12. So 36W stays the same because I can't combine that with anyone. The K stays the same. I can't combine it with anyone. But the 15 and 12 I can combine, and I get 27. So here are my three expressions. This one, my two expressions, sorry. This one and this one that are equivalent to my original. Okay. Rewrite the following numbers in exponential form using three different bases. Okay, so what does that mean? It means that I want you to write this with exponent 81 as an exponent, as a in exponential form. So what number times itself gives you 81? Well, one of them would be the obvious, 9 to the second power. Well, it's not done because I'm asking you for three different ways of writing 81 with an exponent. So is there anything else that you can think of that multiplied by itself would give you 81? So take a little time to think about that. And one of the answers, well, 9 to the second is the obvious one. One of the other answers is this one. 3 to the fourth power. Because 3 times 3 is 9. 9 times 3 is 27. And if I take 27 times 3, that also gives me 81. So another way of writing 81 is also 3 to the fourth. And we need one more. Can you think of another number that multiplied by itself or raised to an exponent that gives you 81? And if you did think of this one, you're on the right track. It's 81 to the first power. That one probably was a little bit trickier. 16, same thing. Can you think of three numbers that raised to an exponent would result in 16? And I think the obvious one is this one, 4, right? 4 to the second power, because it's 4 times 4 is 16. So another number would be, and 2. Would be 2 times 2, which is 4. 4 times 2 is 8, and 8 times 2 is 16. So 2 to the fourth power is also right. And notice that, obviously, the last one, once you're get used to this, you also know that 16 to the first power is 16. Okay, notice the relationship between these two numbers, these two bases, and these two bases. Hint. Okay. Is that it? Wow. Okay, that's it. Oh, your bonus word. Here's your bonus word. So I gotta think of something. And no. There you go. Nice. Name of a legion, Roman legion back in the old days. So the ninth. Okay, and that's your bonus word.